into quadratic equations. Okay, the first thing we're going to do is explore the quadratic equation on your calculator. Am I recording? Yep. All right, so here's what you're going to do. You're going to, on your calculators, on your y equals button, are you there? Are you there? Are you there? Are you there? We're going to put the parent function in for a quadratic equation. And that parent function is y equals ax squared. Everything we do is going to be compared to the parent function y equals ax squared. So that y equals is the key on your calculator. So you're going to press the y equals key and you get this menu. Then you're going to put in 0.25 x squared. So let's put that in. 0.25. Your x key is up here. See the x key? Everyone can have the x key? Everyone? And then square key is right there. Are you with me? Then hit the graph key, which is right here. Now, bless you, my son. Bless you. You okay?
Yeah, I'm good.
Okay. Need a priest or anything? All right, so I press the graph key, and lo and behold, yours probably doesn't look like mine, does it? I hope not. If your graph didn't come up, what you're going to do is hit the zoom key, and you want the standard graph or the standard setting. So you could either scroll down to zoom standard, hit the enter button, and lo and behold, it brings up the standard graph. Now everyone's should look like that, right? Anyone look different? Anyone? Anyone's different? Everyone has the same graph? Anybody sleeping? Okay. So we're going to sketch this graph onto our little graph here in the paper. Now, probably saying, well, how do I do that? Well, remember back when you were just learning how to graph lines and everything, the x value and the y values, you put points and then you connect the points. You had like a little t-chart, you know, your x values, your y values, and then you would make a chart. Well, you chose the independent variable x and then you solve for y. Your calculator does that for you. Second graph. So hit the second button and the graph button, and lo and behold, it brings up that t-chart. Now I'm going to scroll mine down to 0, 0 and get a couple of negative numbers in there too so I can get some points. Now I'm going to choose the points that have whole numbers because I don't like graphing decimals or fractions. So I have the point 0, 0. So here's 0, 0. Positive 1, well, that's a decimal. So I'm going to go to 2, 1. So 2, 1. And I'll do one more positive 1. I'm going to go down to 4, 4. So 1, 2, 3, 4. 1, 2, 3, 4. Here's another point. I got to pick up some negative numbers. Let's see, I'm going to go to negative 2, 1. So negative 2, 1. And I'm going to have negative 4, 4. negative 1, 2, 3, 4, 1, 2, 3, 4. And I can draw my shape. That goes on forever and ever and ever. So, knowing that, I'm going to put little arrow ends on there. Everybody there? Everybody have the graph? Everyone? Everyone? You don't get the graph thing? Let's see what you got. Where's your graph? Oh, yeah. Okay. So, second graph brings up the point. Anybody else? Anyone? Anyone? Right. 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 Right there. Why not open up the package? I don't know. Well, just saying. Good. For those of you who want to learn math and get a degree. Huh? Yeah, not have to take algebra 1 again. All right, so you guys do the rest of them. Do B, C, D, and E. Go ahead. Go ahead. On your calculators. Go ahead. Go ahead. Do it. Go ahead. Sure he doesn't want somebody to help him. Don't have the whole group. I am officially mad. Yeah. Do me like that. Yeah, because I brought $250 check so I can pay the rest of my cabin and they won't accept checks now. Why? So there's other people writing checks that they don't have money for, so then they get their stuff basically free. Oh my gosh. Before school starts, I would draw $250. Well, that stinks. Where's the way? Do this. Good going. Good night. 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 Yeah, that's another Algebra 2 student from yesterday.
He who stamped that?
Yeah, he did it himself. I was proud of him.
I forgot how to do the graph.
Put in the y equals button.
All right. This one.
0.025 x squared. Hit graph, and then you need to hit student standard. Okay. Then go to second graph and get your points.
Well, were you paying attention?
Okay. What's common? Oh, they're symmetric. Man, nobody has ever been that creative and seen that right off the bat, ever. So if I split these in half, the one half is exactly like the other. That's called symmetry. They're symmetric. Wow. In fact, this line right here is called the axis of symmetry. That is fantastic. That gets like, we got to get you a trophy for that one or something. Axis of symmetry. Notice it goes through this point. The point that makes the graph turn around. I need another color. So it goes through that point, that point, that point, that point, and that point. Anybody know what that point's called? It is the origin on this particular function. This is called the function, quadratic function. But for the graph, it's called the vertex. Okay, the vertex. So my axis of symmetry goes through the vertex. Wow, all that just because we noticed that they split in half. That is fantastic. Okay, so they have axis of symmetry. They're symmetric. They all have a vertex. What shape are they? They're U. They're U-shaped. Anybody know what we call the U shape? Anyone? 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 It's called a parabola. Parabola. I used to have a student say, well, actually, it's a parabola. And if you think about it, it should be pronounced parabola. But we call it a parabola. Okay. All right. Let's look at, that's some pretty good common things about these graphs. Has a vertex, has an axis of symmetry, they're symmetric, and they all have a vertex. Okay, let's look at the next one. Under what conditions does the graph y equal ax squared open upward? Well, think about this. Which ones open up? A, C, and D. Okay. The ones that open down are B and E. So look at these equations. What's the difference between A, C, and D and B and E. There's a negative sign there. That's fantastic. See how Nicholas there is just spitting things out? Okay, there's a negative sign with B and E. So, for it to open upward, A has to be what? Positive. And for it to open downward, A is going to be negative. Okay? I'll put it over here. Okay, H. As the absolute value of A increases, so we're talking about the absolute value. Remember the bars? The absolute value of A increases. Now, what does the absolute value do? Anyone? 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 Bueller? Anyone? 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 My first semester Algebra 1 students, remember we did absolute value? You remember, Esco? Absolute value is the distance from 0. So if I go negative, if I go positive, okay, here's my number line. Here's 0. If I go to 3 this way, I went 3 units. See how it's positive? If I go 3 this way, -1, -2, -3, how many units did I go? That's right, 3. See how my distance is always positive? So whatever comes out of my absolute value is positive. In other words, A can be negative, making my parabola open downward, but we're talking about the absolute value of A. As it increases, so as my A goes from 0 to 1 to 2 to 3, what happens to my parabola? I know that's here my A is what? Let's go back and figure out what the A's are. 1 quarter, right? 0.25 is 1 quarter. What's my A here? 0.5. Well, we've got to do the absolute value. So it's -1/2, right? But my absolute value is 1/2. What's my A here? 1. What's my A here? 2. What's my A here? Yep, 5. Okay, so if you notice, what's happening to the values of my A with these graphs? What's happening to the value, the absolute value of A as we go along here? They increase. Wonderful. Just spit it out when you get it, okay? So A is increasing with these examples. I know you guys can do this. Not just Nick. I got a feeling all of you can do this. So as A, the absolute value of A is increasing, what is going on with my graphs? I have faith in everybody can figure this one out. I know you can. Just think about it. Look at the pictures. What's happening to my graphs? Let somebody else answer. Anyone besides Nick? Anyone? 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 The question is, as my absolute value of A is increasing, notice A is increasing here, the absolute value, what's happening to my graphs? They're changing. Okay, they're changing. Esco, how are they changing?
Up and down, up and down.
Okay, we're talking about the absolute value. Okay, so it doesn't matter whether they're positive or negative, they're all going to come out positive. So what's, we might have another person here. Do you know, Esco? What's happening to my graph? Well, I'm going to give Talia a chance if you help you out if you can. Okay. All right, Talia, help them out. They're getting closer. They're getting narrower, right? See how they're getting narrower? They're actually like a rubber band. They're being stretched, right? They're getting narrower. Everybody get that metaphor there? See if I got a rubber band here. See? Rubber band? If I stretch this, it gets narrower and narrower, right? So they stretch. So as the absolute value of A increases, they get narrower, and mathematically we call that stretching. Okay? As they get narrower, that's the mathematical English term, narrower, they stretch. They're stretching. They get closer together. Now, what do you think happens when A decreases? If the absolute value of A decreases, yeah, they're going to get wider. They're going to expand. They're going to get wider. So the smaller the number, the wider they get. Huh? And mathematically we say compress. See, if I compress the rubber band, it gets wider and wider and wider. If I stretch it, it gets narrow and narrow and narrow. See? Isn't that cool? What a great, great metaphor. All right. Whew. I think we might stop there. You know what? Let's keep going. We got 10 minutes, right? This class gets out at, yeah, we got plenty of time. So I don't care if you use, it gets skinnier, it gets narrower, more narrow, it gets wider, it gets fatter, it compresses. I don't care which one you use. You don't have to use the mathematical terms because I don't think anybody requires it after this course anyway. So we got a lot of stuff going on here, right? Just by looking at the pictures of the graphs. Isn't that cool? Don't you find that fascinating? I can all see the looks on your faces. You should see them all. Turn around, look at the people around you. Look, they're all excited about this. All right. By the way, you could put on your calculators, you can put all of those in there, and you can turn them on and off by highlighting the equals keys, by hitting the enter button. So I could pick either one and graph it just by turning, putting your cursor over the equal sign and turning it on and off. What's really cool, this will blow your minds. Be careful. Turn them all on. And then graph them. Wow. Holy moly. Is that cool? Wow. I forgot my negative sign on one of them. second insert negative. Ooh, wow. Ooh, wow. Isn't that cool? Especially if you have a color screen like mine. I could do that all day long. You don't find that fascinating? I don't know, man. You should see the looks on your faces. All right, let's go down to number 2. Let's go ahead and graph all these. So I'm going to go back to my y equals, because these are equations. I'm going to clear each one of these. You probably only have one. I'm going to put all these in here. 3x squared plus 4. 3x squared plus 2. 3x squared minus 2. And 3x squared minus 4. Now, I'm just going to turn the first one on, because I just want to see what happens when our a, here our a equals 3, right? So what do we know? First of all, what do we know compared to our parent function, y equals ax squared? We know that a is going to be 3, right? A is 3. So we know that it's going to be, let's see, a increases. We know it's going to be narrower, right, than the parent function y equals x squared. We also are adding a constant to it. Okay? So now we're in the form of y equals ax squared plus c. What do you think that 4 is going to do? Anyone? 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 You? Anyone? Think about it just for a sec. What do you think the 4 is going to do? We know the 3 is going to make it narrower. Any ideas on the 4? Wider? The A is what makes it wider and skinnier, right? So try a different scenario. Anyone? 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 Bueller? Bueller? Huh? Well, let's see what happens. Oh my gosh, what happened? Look at that, how exciting it is. What happened? Not only is it narrower, but it moved it up 4. Holy moly. Oh my gosh. So I'm going to graph this. I'm going to get a couple of points. Let's see, 0, 4. 0, 1, 2, 3, 4. Negative 1, 7. So, oh my gosh, I could like way up here. 1, 2, 3, 4, 5, 6, 7. Way up there. Way up there. So there's my first parabola. Hey, what do you think is going to happen with the positive 2? Hey, it's going to move it up 2 instead of 4. That's fantastic. You guys are getting the hang of this now. Now I'm really getting proud of you. How about negative 2? Yeah, it's going to be at negative. My vertex is going to be at negative 2. That's going to happen. Go like that, that, and negative 4. Wow, cool. That is so slick. So, how does the value of c affect the graph of y equals 3x squared plus c? It moves the vertex on the y-axis. So if it's on the y-axis, it's moving up or down. Okay, at what point would the graph y equals 3x squared minus 4 intersect the y-axis? Well, that was this one, at negative 4. At C. At C. How about 3x squared plus 5? Well, it's going to be C at 5. Pretty cool, huh? We didn't even need our Chromebooks today. We did all our fun, on a calculator.